Video we shall be solving simultaneous linear equations, but we will now be solving word problems that will lead us to simultaneous linear equations. Let's start from this first example. It says a woman's age and her son's add to 45 years. 5 years ago, the woman was 6 times as old as her son. How old was the woman when the son was born? Now we are going to be taking it bit by bit. For solution, a woman's age and her son's age add to 45 years. Now we don't know how old the woman is or how old her son is. So what we are going to do is we are going to have letters, alphabets that will represent the woman's age and the son's age. And now since X and Y are the most common letters used for representing unknowns, we are going to say let X equal to the woman's age. And then let Y be equal to her son's age. Now, wherever we see X, we know it's the woman's age. Whenever we see Y, we know it's her son's age. Okay, so let's take the first part of this problem. A woman's age and her son's age add to 45 years, meaning that X being the woman's age plus Y being the son's age add up to 45 years. So this is our equation 1 we've gotten from the word problem. 5 years ago, the woman was 6 times as old as her son. Now, if the woman is X years old, now, that means 5 years ago, she is whatever age she is minus 5, right? Good. So 5 years ago, the woman was X minus 5 years old. So this is her age 5 years ago. So let me just write it. 5 years ago. So we can just remember, why are we writing X minus Y? And that same 5 years ago, her son is also whatever age he is now minus 5. So this is 5 years ago. I believe we understand that, right? Okay, now let's go ahead. So 5 years ago, these were their ages. Now let's look at the question to see what it says. 5 years ago, the woman was 6 times as old as her son. So this woman is now 6 times older, like 6 times as old, meaning that whatever age her son is, times 6 was the woman's age. So remember, this is her age 5 years ago, which is X years minus 5 is equal to 6 times whatever her son's age was those 5 years ago. So we formed the two equations. So this is 5 years ago. This woman's age is 6 times her son's age. So we've now been asked, how old was the woman when her son was born? Now, our duty is to find out how old is this woman right now, how old is the son right now. And we know, whenever we find that, we can always know how old this woman was when her son was born. That's just a little part of it. It's nothing to us anymore. Once we know a parent's age and the child's age, we just minus it to find out how old they were when they had their child, right? So that's not an issue. The issue for us now is to find out how old is this woman, that's this X, and how old is the son's age now. Why? Now let's delve in. We are going to open up these brackets so as to get a simpler equation. We have X minus 5 is equal to 6Y, that's 6 times Y. 6 times minus 5 is minus 30. So we collect like terms now. We have X minus 6Y, that is the unknowns coming over to one side, is equal to minus 30 plus 5, which is minus 25. Therefore, we have that X minus 6Y is equal to minus 25. Now, we could actually use substitution method to solve. When we use substitution method, we can from equation 1 form this thing, or we could use elimination method. Any of the methods we want to use, we can use it to solve. Now let's use substitution from equation 1. Equation 1 can take us to say that x is equal to 45 minus y, right? X is just here, plus y goes over to become minus y. So we substitute into equation. Let me just have this one as equation 3. That's the modified equation 2. Okay. Substitute 45 minus y for x in equation 3. We now have that wherever we see x, instead of having x, we're going to have 45 minus y. Remember, it is minus 6y is equal to minus 25. We open up brackets. When we open up brackets, it's just to collect, like we have 45 minus y minus 6y is equal to minus 25. We collect like terms. Minus y minus 6y is minus 7y. And here we already have minus 25. 45 crosses over to be minus 45. Now we have minus 7y is equal to minus 25 minus 45. 5 plus 5 is 10. 2 plus 4 is 6. So that is 70. We divide both sides. Minus 70, remember? We divide both sides by minus 7. So we have that y is equal to 10. We can see that. And remember, we said that y was the son's age, right? Y is her son's age. Therefore, her son's age is 10 years old. The son is 10 years right now. And from equation 1, that says that their ages add up to 45. Therefore, to find x is to now say x plus 10, that is the son's age, is equal to 45. And therefore, x is equal to 45 minus 10. Therefore, the mom's age, which is x, is 35. Now, let us make a check to see if these answers are true. Now, let's start. We say that x plus y is 45. 10 plus 35 is 45. And we said 5 years ago means that the mom's age is 35 minus 5, which is 30. So 5 years ago, the mom was 30 years old. 5 years ago, the son, who is 10 years old now, was 5 years old. Let us see if the mom's age is actually equal to 6 times the son's age. 6 times 5 is actually 30. So these values we've gotten are true values. Now remember, the question is asking us, how old was the woman when her son was born? Now, if this woman is 35 years old now, and her son is 10 years old now, we already know that she was 25 years old when she gave birth to her son. Now, we now say the woman was 25 years old when her son was born. We can see we just take it gradually. Now we've been presented with another question. The perimeter of an isosceles triangle is 28 cm. And this is the isosceles triangle, and we've been asked to find all these x and y, and hence state the length of each side of the triangle. Now we know that an isosceles triangle has two equal parts. So these are the two equal parts, okay? Then this side is the unequal part. And we know that perimeter is addition of all the sides, the sum of all the sides. Now we are going to form equations out of that. As a means of solution, we have that first, perimeter is 28 cm. Therefore, all these sides of the triangle, which is 4y plus, that is this part, plus this part, 6y minus 2x plus 1, that's this part, plus now the third part, x plus 2y, and they are all equal to 28 cm. So this is what we know, the perimeter is equal to 28 cm. Now let's collect like terms, so we don't have this untidy representation here. We have all the y's that to be collected together. We have 4y plus 6y. So we've gotten this. Now remaining 2y plus 2y. Okay. Now for the x part, we have minus 2x. So we've gotten this plus x. And then the value remaining is plus 1 equal to 28. Now 4y plus 6y is 8y. No, 10y plus 2. Minus 2x plus x is minus x. And then this is 28. This plus 1 crosses over to be minus 1. Therefore, we have that 12y minus x is equal to 27. So this forms our first equation. Okay. Then, from the triangle, we know that these two sides are equal. That is 4y cm plus this are equal. That forms our second equation. We have that 4y is equal to 6y minus 2x plus 1. We collect like terms. When we collect like terms, we are going to have minus 2x crosses over to become 2x. And then we have 4y already here. 6y crosses over to be minus 6y is equal to 1. Okay, we have 2x plus 4 minus 6 is minus 2y is equal to 1. This forms equation 2. Now from equation 1, we can form a substitution relationship from equation 1. Okay, so from equation 1, we can have that x, that is, we send x across here so as to avoid negatives. We have that 12y minus 27 is equal to x. Therefore, we can substitute this into equation 2. Doing that, we are going to have, wherever we have x, we have 12y minus 27. We have 2 into 12y minus 27 minus 2y from the equation equal to 1. We open up brackets. We have 24y minus 54 minus 2y equal to 1. Now we have that 24y minus 2y is equal to 22y is equal to 1. Minus 54 crosses over to be plus 54. So we have that 22y is equal to 55. And we divide both sides by 22. We are going to have that y is equal to 11 goes here to be 5, goes here to be 2. So y is equal to 5 over 2. Or, which is equal to, y is equal to 2.5 cm. Now let's find x. We are going to find x from this relationship. We have that 12 into 5 over 2 minus 27 is equal to x. 12 times 5 is 60. Let us 60 over 2, that is 12 times 5, 60 over 2 minus 27 is equal to x. 60 over 2 is 30. 30 minus 27 is equal to 30 minus 27 is 3. Therefore, x is equal to 3 and y is equal to 2.5. Now, we've been asked to find all the sides, the length of all the sides of the triangle. Now, let me do that here for want of space. We have that one side is 4y, which is equal to 4 times 5 over 2, which is 4 times 5, 20 over 2. that side is 10. Now this other unequal side, the unequal side is x plus 2y, which is equal to x is 3 plus 2 into 5 over 2. 2 times 5 is 10. 10 over 2 is 5. Therefore, that side is 3 plus 5, which is 8. Now, the test whether all these things are equal is actually when 4y equals that other side that has 6y minus 2x plus 1. Now, let's check. If it is actually equal to 10, then we know that everything we solved is correct. So this solving for the third side is also a check. We have 6y minus 2x plus 1. For this part, we are going to have 6 into y is 5 over 2 minus 2x, which is minus 3, minus 2 times 3 plus 1. We have that 6 times 5 is 30. 30 divided by 2 is 15. So we are going to be checking whether 15 minus 2 times 3 is 6. 15 minus 6 is 9 plus this one is equal to 10. Therefore, the sides of the triangle are 10, 10, 8, and everything we got, we are equal. That is x is equal to 3 and y is equal to 2.5. We now have another one presented to us. In a positive number of 2 digits, the sum of the digits is 15. If the digits are interchanged, the number is increased by 9. Find the number. A positive number, that means it's not a negative number. The sum of the digits. So now let's say the digits are x and y. So the positive number has two digits, right? So let's say x and y, something like when we have something like 25. So 2 is a number ahead. So x and y, the sum of the digits, x plus y is equal to 15. So this is one equation we formed from here. The sum of those digits are 15 or is 15. If the digits are interchanged, the number is increased by 9. Find the number. Now let's have a way of representing this number. We have that if the numbers are this, so this is the one on the tens side. Any two-digit number has tens and units, right? So the one on the tens side, we are going to say 10x. Because whatever digit it is from 1 to 9, right? And is on the 10 side, so it has to be multiplied by 10. Just like I'm using 25, for example. That 2 there is not just 2, it is 2 times 10. That is 20 and 5. Do you understand? So, that is why we say 10x. Okay, something like saying 10 times 2. That's to give us the 20 that will make 25. I'm not saying this number is not even 25. So, I'm just using that to clarify why are we putting 10x here. So, 10x plus y. So, this is the number. If the digits are interchanged, the number is increased by 9. So this is the number, original number. It will be increased by 9. That is, it will add, 9 will be added to it if these digits are interchanged. If the unit side now comes to be the tens side. So this is now the unit side, y comes to be the tens side. Plus x now becomes the unit side. So this equation now forms equation 2. So this number, if they are interchanged, it now means that whatever this value is was increased by 9. Increase means addition. Okay, so we formed the two equations. We have to arrange this one and make it, we have to collect like terms. So we, opening of bracket is 10x plus y. We have 10x. Then when we bring this x over, it becomes minus x plus y from here. Then this 10y crosses over to be minus 10y is equal to plus 9 crosses over to be minus 9. So 10x minus x is 9x plus y minus 10y is minus 9y and it's equal to minus 9. Now everything in this equation can be divided by 9. We can actually do that so as to have a simplified equation. When we divide all through by 9, when you do same thing to every part of the equation, you've not really changed the equation. It still remains authentic. So we divide all through by 9 to find that x minus y is equal to -1. So this forms our equation 3, the arranged form of equation 2. Now we can actually do this. We can actually use substitution method. So from equation 3, we have that x is equal to minus y crosses over to be y, and then -1 is already there. Now we are going to substitute this into equation 1. These are very simple equations. So we substitute into equation 1. We have that wherever we see x, we're going to say y minus 1. So y minus 1 for x here plus y is equal to 15. That's from equation 1. We open brackets, y plus y, that is y plus y minus 1. Okay, let's send the -1 across. So it's equal to 15 is already here. -1 crosses over to still be plus 1. We have that 2y is equal to 16. Therefore, y, we divide both sides by 2, y is equal to 8. Then we solve here. We have that x is equal to y minus 1. So x is equal to y, which is 8 minus 1, which is 7. Okay, so x is 7, y is 8. Find the two digits, x equal to 7, y is equal to 8. Now the digits, remember that x is on the 10th side. Remember from here, x is on the 10th side. That means it is 78. The number is 78. The number. Now we are going to test out what the question says. The question says that when we add the two digits, it's equal to 15. 7 plus 8 is actually 15. So passed. Now the second part says if we interchange the number, so instead of being 78, if the number becomes 87, that it means the original number was increased by 9. Now 87 minus 78 is actually 9. Therefore, this is the correct value.